Hello. All right, so let me go ahead and tweet about this. Since we have 2 more minutes. And I don't want to hear my stream. I will just mute this. Since we have okie dokie. And I don't want to hear my stream. I will just mute this. Since we have okie dokie. And I don't want to hear my stream. Since we have okie dokie. And I don't want to hear my stream. Undo retweet with comments. And retweet with comments. All right, so we're live. Let me see if we have anyone. Oh, wow. Жуткое echo. What does it even mean? Live. Let me see if we have anyone. Oh, wow. Жуткое echo. What does it even mean? Live. How about now? Echo should not be the problem anymore, simply because I do. All right. In case I want to play some of the music, but there should be no echo, so everything should be fine. Just wait for a second. And there should be no echo. My my YouTube says the stream is healthy. Stream is healthy. Everything is fine. Connection is excellent. It's fine now. All right, great. Okay, so let's start. Let's start doing stuff. Let me share my screen, and we will go. Share screen. Let's go here. Just a quick recap of what we're going to be talking about. So, where's my keynote? Yeah. So, thank you so much for joining me for this stream. The purpose of this one is just a little experiment. I'll see if I will be able to do this more regularly, so we can talk about some things that obviously in interest of mine, and somehow you also will be interested, but you can always influence some of the themes for the stream. We'll see how it goes. We'll see how long I can go. And this is not what she said. Anyway, so the purpose of today's stream, actually, you know what? That's nice looking guy. Let's close him. We don't need to do this. We'll do camera for now. So, couple weeks ago, I did a presentation about running Kafka Streams with Kubernetes. I don't know, maybe it's my fault because I cannot control my time, or I'll get too excited talking about certain things. But for some reasons, like I didn't have a time to show the demo. Some of the users in my Russian Telegram channel points out, and some people on Twitter point out that like it's a good presentation, but very short on demo. So I decided, okay, so let me spend some time with my people right now online, and I'll try to break this demo for you, and we can talk about some of the bits and bytes of this demo. So let me see. Everything is fine. So let me start sharing. In this case, not going to be slides. I promise it's not going to be slides. It's going to be only black screens and sometimes talking head. All right. So it's a very nice screen to open and see some exceptions. This is fantastic. Let me clean this up first. We're going to be seeing this one. We're going to be seeing this screen. I just want you folks just to type into chat. I guess right now chat we have is on YouTube. If font size is fine, everything sounds fine, and everything looks good, so we can continue. So if we got disconnected for some reasons, this is in these modern days, we don't know what might happen. All things what I do usually goes on this repository called demo scenes. The things what we do in general in Confluent around stream processing, Kafka, and all the things are going to this the demo scenes. There's some cool things. Some things might work, some things might not work. It's like a fully conference-driven development type of repository. If you want to see some of the curated demos that always work, you can find this in this repository. It's called Confluentings Examples. It's like always works, validated through CI/CD, and always up to date. But not gonna be talking about this today. My favorite place where I do all things around Kafka Streams, and today we're gonna be talking about Kafka Streams, as I promised. This repository that we developed together with my my friend and coworker Tim Berland. Essentially, it's the idea of real-time rating generation application, and all things that, if I want to emphasize, usually I will try to explain this using this presentation. It has some data generators. It has different versions that might be working with databases. And today we're going to be using just simple off the bat the Kafka Streams application. We will I'll show you how I package application in Docker. It's easy. I'm gonna be using Artifactory here as example of custom Docker registry, because everyone is doing Docker Hub. It's easy. Like how you're gonna be dealing with the repository that is not Docker Hub. Most likely in your organizations is not Docker Hub. You might have your own private repository. And after that, I will be deploying everything in Kubernetes, and my Kubernetes cluster will be in GKE. Why GKE? No particular reason. I just like their user experience and their command line tools. So, I'm just checking. Where's your 1000p? I think for now we're good for just HD. My hardware appliance that's supposed to stream in full HD is coming into mail, and right these days mail is not working. So for now it's gonna be only HD. Okay, now so let's get to repository. Usually I trying to put things into README, but in some cases they might be not up to date. As I said, like the machine repository is not always up to date, and things like that. So there's a couple of things. If you want to start just with basic idea what kind of application I will be running, it's here in my Streams project. Everything is Gradle here. It's one of the Gradle projects. Essentially, idea is two topics, one topic with movies, one topic with ratings. We will materialize the movies as a table, so it's going to be our lookup, and we're going to be enriching the new stream that will have rated movies table based on the arriving rating. So we will also reading data, we generate some of the data into ratings table, the rating stream, excuse me, and we do how it's called, the also parsing of the stream, and after that we'll do a join between movie streams. The topology looks relatively simple. Actually, let me show you a very cool tool that I use to I'll just run this just to speed up. It might not even work because by default it uses local host, and the local host is not there. I don't even use this thing. Where is it? Kafka Streams app topology describe to stream. Okay, so if I will use this, I need to specify. Yes, do run. I need to specify some parameter. Run. Edit configuration. In this particular case, I need to provide the program argument, and in this case, it's going to be my, actually, it's probably in somewhere in my build script. So if I have any run thing here, run generator. No. We have a loader. We have run app and get config. Okay, so let's see if we will be able to run something. CD stream movie demo. We're in the right place. Everything is here. So let's just see run app. If I have a okay, let's see. I just want to run this, make sure that I don't have any compilation errors. And also I want to show you some of the things that I like to use to visualize stuff, what is going on here. Hope this works. All right. Looks like it does work. Let me switch to my browser screen. So the tool that I use here to understand the Kafka topology called Kafka Streams Topology Visualizer. It's a GitHub project. It's pretty cool. So the way how it works, I think it's not getting this result correctly. So let me. I think the topology is broken right now. So let me just copy it here. So yeah, I need to come up with better solution than just base 64 this topology and pass it as a URL. I'll do here, remove everything, put it here, click update. Yeah, that's better. So the way how it works, Kafka Streams provides some of the cool API that allows me to describe topology. Once I build my topology, in this particular case, I build the topology, everything is ready, and I can just describe it, and it would speed up something like this. This is like a textual representation of the topology, and after that, this visualizer tool able to build a topology. Let's take a look what I have here. So some of the things that outside of this the graded stuff, it is a what we called external things. So in this particular case, it's Kafka topics. The Kafka topics that we're going to be using, they are outside of topologies, but they will be used as a source or as a sink at some point. So 2 topics, as I said, ratings and the movies. And this is something that we do here. We reading movies. We do some transformation, and we do filtering, and we do write this result in some aggregated state store. So let's take a look how the code looks like first of all. So first topology part is a raw rating stream. So we start our streams builder. We go in here inside, and what we see here. This is raw ratings. We start by creating new stream from here. And this is how we're getting average table. So first one, we getting the streams of ratings in a format that looks like this. You can find this in a data directory, and there's a ratings.dat. It is very, how it's called, enterprise friendly format. Like it's a pipe separated or like a column separated format. It's ID, movie ID, and rating value. So in order to deal with this stuff, we need to get something useful out of it. So in this case, we have, we call it this map value. So we're getting results in one topic. We apply a mapping function. In this particular case, we apply this parsing function that will generate our the rating object. And rating object in here, it's Avro object. And the second thing is we actually do rekeying, because by default, usually when you're dealing with streams, you don't know in kind of format they put this data. So we assume here the data come from some system that doesn't know any notion about the keys and the locality of the data and whatnot. So in this particular case, we need to also rekey the stream. So that's why you will see first one is map values. The first one, we do map function. After that, we do map values. Here, it's interesting. The map values, where is it? Yeah, so the first one, we do map values. This is where we're parsing. After that, we're performing mapping function. And there should be some filtering here. Interesting. So filter, this is something that I need to investigate. I don't know why it's here. And the result, we're getting a aggregated state store inside inside the topic. So in this case, we do things like this. So we're aggregating stuff. The next thing is that we're doing similar thing with movies. We're also reading movies, we're parsing movies and put them in the movies topic. And also now we're doing some interesting stuff. We do essentially join of these two in this case, where's our ratings? And let me switch back to movies. This is movies table. And inside the movies table, we generate this movie, obviously, and also we're creating local state store. So in case our application needs to expose this information in the interactive queries, we can talk about the interactive queries in further, like in the next stream, if you would like. So let me know if something that would be interesting to know. Let me actually see if anyone is commenting something. All right. So this is why I like Russian community. People already start providing me with some advices. Like I said, I'm not gonna use a software solution. Software solutions suck balls. I also get in the hardware solution. So stay tuned for the next episode. But I hope the final result would be much better. Hopefully, YouTube will be able to translate this nicely. Also, I will see if Zoom will be able to support like much higher resolution. Now, application has this the topology. We're going to be running this, and as a result, we will have one topic called rated movies. So we'll have information about movies, information about ratings joined in one object. Now, let's take a look at Kubernetes and essentially aspect that related to containers. Where is my there is a project called Streams Kubernetes, and I need to open the build script. And I say Kubernetes. Okay. And couple things. So I built this Java application, and because I don't want to write my own Docker files every time, I'm using this plugin called Jeb, which is Google. So switching here to where's the GitHub? They have a Maven plugin, Gradle plugin, and standalone project. I'm using Gradle plugin, and in this plugin, I will just simply specify what my application here. It will just simply take results of my main application. That's going to be like a shadow jar, and produce image. In this particular case, building this stuff and getting things to my Docker registry will be, in this case, as Artifactory Cloud. I don't know why you're complaining. I'm just having this the stream on in other window. It looks fine. You know, the black screen, the letters are big enough. It's okay. It's gonna be fine. Next time it will be better. All right. Next thing, we need to have a Kafka. Again, there's like a lot of things how I can run the Kafka. Let me know if you want to talk about Kafka and Kubernetes. I just want to have like a simplest, effortless thing, at least for me. I will just want to use Confluent Cloud, and I do have a cluster for that matter. So I will create a key. I should probably not showing this key to you because someone will hijack this. You know what? Let me not doing this. I will just do this one. I will delete this key. And I will copy these keys in the second window, and I will get back to this on another browser window. How I can zoom window? It's terrible. Go and disappear. Yeah. Okay, I'll let me just copy the keys, and after that I'll get back to you. So essentially what I'm doing while you're not looking, I do have some, just do go rename a rename dot config dot back. Creating new file config, and this is where my key goes. Come on, where is it? Okay, key and value stream live demo, and I will copy snap. I forget, too many things is going on the screen, so stay with me. Stay with me. Okay, copy secret. Okay, cool. Live stream. Live streams. Wow, I think it's a good name. Also, like, let's use this opportunity to come up with good name for this type of show. My imagination only ends on live streams, which is essentially it's kind of lame, right? It sounds very lame. Okay. So next thing is that tools and clients and configuration. Clients, I'll do Java, copy to clipboard. And I will just copy. It's going to be my Java, Jing. Okay, so cluster username is going to be my key. And it's going to be my password. Another thing that I need to have is schema registry. And for that, API access, add the key, copy. I will do, okay. And okay. I think we're good. Now, I think live streams, save, yes, okay. Let me get back. So let me show you, okay, too fast. Yep, let me show you quickly what I did. So I have my Confluent Cloud cluster. I just defined the configuration that I will be using. There's only a few things that I need to know. Is essentially my key and the secret and stuff. So let's see if our connectivity works. So okay. All right. So Kafka Streams application reset, application ID, Kafka Streams application reset, Kafka Streams. Okay, Kafka Streams application reset, movies. Okay, so URL for this cluster is gonna be this one. Let's see, this is gonna be here. We're replacing this with this stuff. I will using my Confluent Cloud config. Let's see if I will be able to config connection reset offset. Okay, so reason what I did here and stuff what I did, I actually reset my Kafka Streams application because I previously used this for running some demos, and I don't want this interfere with my the current demo. So I will start everything from scratch, and we'll see how everything will go. So now we have a Kafka cluster, and looks like connection is working. we should be able to see these topics go away, like intermediate topics potentially, or maybe not. We'll see if they will not interfere. Now, all right, so question is why I use aggregated store and not joined streams? Because I want to perform a table to stream join rather than stream to stream join, because movies in my case are finite stream. It's going to be lookup. It's going to be using movie ID just to look it up. So in this case, it doesn't really matter. I don't really need to join two streams. So in this particular case, I'm using a table to stream join. Yes, exactly. That's the point. You don't see what I'm doing in the Visual Studio Code, because in Visual Studio Code, I was copying my the secrets from here into my configuration file, and they're super secret and things like that, and the hackers can steal these keys. You know, the information security stuff. All right. Next thing is that, let's see. We need to have a Kubernetes cluster. Now we have a Kafka cluster, we have Kubernetes cluster. So in order to have a Kubernetes cluster, I will be using a in the README file. You can also like do the stuff yourself. You can have these things. In this particular case, I will create this cluster in GCP. It's called Kafka Streams cluster, number of nodes 2. I will be using N1 standard instances, and I will run this in Eastern zone, which is closer to me, I guess. One of the things while it's starting, I actually recommend you to check if you need to figure out the latency stuff. There's a GCP ping or GCPing. .com. There's a very neat small web application that shows like exact latency to your location. So in this case, apparently the Canada is the fastest for me, but like wait. Yes, US East 4 is closest to me. So let's see if I'm using, I'm using US East 1, which is totally fine. It's just a 10 milliseconds difference. It should be all right, right? So that should be not a big deal. So while we're waiting, what this Kafka cluster, Kubernetes cluster will be started. It's up and running. We will just we'll see how this everything will go. So the next thing that we will going to be doing is to actually generate our image. If I go here, Gradle. And in my Gradle Kubernetes and tasks, and when I do, I guess Jib is actually will do the thing for me. When I run the Jib, it will compile Java because I set dependency on the Java project, and after that, it will grabs this stuff and publish to my artifactory. So my particular case. Okay. Okay. I also need to drop these two topics because. Okay. Come on. All right. So everything is okay. So I build the image. Image successfully published in my artifactory. Not found because probably there's no public access. There's no public access, and where's my? Come on, just go away. All right, so where's my Docker images? Never. Stream. Movie. Where's my packages? Package view, Docker, Dirge. Okay. Come on. Movie rating. Streaming. Come on. Streaming movie ratings. Yeah, we need to call experts for UI because search in Artifactory is always nice. Nice thing. So yeah, we do have something here. So it's somewhere here. Should be all right today, right? This is today, and we do have something. Okay. Happily serving 13 artifacts. Perfect. Now, next thing, time to do some stuff with Kubernetes. Let's see if we have a cluster is up and running. Okay. GP. No pods. Okay. CTX, just to make sure that it successfully switched to write. So we have a streams US DevX testing, US East 1C Kafka Streams cluster. Okay. Okay, NS, no spaces. Yeah, I think we're good. The cluster is up. So let's try to do two things. So first thing is that we deploy this simple application as a simple deployment. And a couple things here. Couple things here specifically. So when we do have those things, we actually host those things in the Kafka cluster, but this state stores, this state store and this state store, they actually will be stored in using RocksDB. By default, I'm using RocksDB. I'm not using anything else. So in this case, it is going to be a how it's called, the place where I will be storing this locally to my application. And this is something that looks like many people missed from my presentation. Let me actually bring a quick slide. I will explain this once again. All right, so when we're talking about topologies, each step of the topology will be represented by this graph. And this graph topology will be executed, and I will talk about this per partition. But things like some of the processor node might have a state store, some of these might not have. So in this particular case, places where we're performing some sort of aggregation. So in this case, when we do this group, we're doing this group like windowed or aggregate. This is where we're storing the state. So this is where Kafka Streams will create our state store. Now, what does all this mean? So the way how it works and the way how the scalability in Kafka Streams, like very simplified version. So we have an input topic that has 4 partitions. So in this particular case, when we start one instance of application, one instance of Kafka Streams application, it will create a task that will be executing single topology per partition. So we have a 4-part input topic partitions. Each task will be executed its own partition. Why it's done this way? So in this particular case, each task will be allocated to 4 particular partitions. So you don't need to worry about locking or mutexes on all the things in order to preserve prevent other tasks to read your job. So in this case, it will be very simple. If you have 12 partitions, you will have a 12 task. And important thing to note, those are not equal to threads. So task is more like a concurrency utility that exists in the Kafka Streams comparing to threads. However, it actually can be applied to threads, and it uses one consumer group for application. This is why when you start in Kafka Streams application, it needs to use the application name. So in this case, it will create a consumer group for that. Now, the tasks can be distributed either by thread if everything running in one machine, or by machines. So let's talk about this real quickly. And as you can see here, each individual topology, as I showed previously, will have its own state store. So state store will be available per partition. All right. So the way how we're going to be, the things what we're going to see right now, we deploy one version of this application. So actually it's not 4 topics. We will have 6 topics. I don't know. I just created these 6 topics, the application topics. In this particular case, when we start one application, it will run all this task in the context of one application. Once I start another application, some of the tasks will migrate. And we will talk about state store in a bit, but like I just have this thing in mind for a while, and how this state will appear in another side of the application. I will show in a couple more minutes. So let's start with like simple use case. All right. Are you folks still here? Can you just like wave in this in the chat? I see like some people are still watching, and I appreciate you. Just like wave something at me so I would know that I'm not talking to myself. You know this joke, right? When it's not a problem when you're talking to your walls, talking to a cabinet, talking to a camera. It's actually a problem when it actually replies to you or like answers to you. So hopefully I'm not hi. Okay. All right. So we do have a 2 type of deployment in this case. Let's start with like a simplest possible deployment. And I apologize for YAML. Okay, so I don't like it either, but where's my yeah, something like this. Let me know in the comments if you want to see the same stream when I will be writing my deployment using Kotlin. If you're interested in this type of jazz, I did some presentation in the past. Hopefully, if you would be interested, I can definitely replay this. Now, simple deployment. What does it mean? In deployment, it's just one of the simplest resources that are available in Kubernetes. We can do the deployment of the pod, but like if pod will go down, we need to manually bring this up. Deployment provides the way how this pod will be restarted in case of failures and so far and so on. Only one thing that I'm specifying here is we will talk about affinity in a bit. So for now, like I will just do it as it is. My individual application will be running on individual node. So it's going to be kind of fully dedicated. And also here, I'm not specifying any state. Let's see if we will be able to run this. In order to run this, again, we'll just do, okay. Movie ratings deployment YAML. Okay. Streams, what's the Kubernetes? And all right, I expected this. So what happens is, since I published this in the registry that doesn't Google doesn't have a like direct connection, I need to also enable this. Artifactory, Kubernetes, registry, configuration, whatnot. And hey, it's a blog. Let's see if we will be able to Kubernetes Docker registry. Let's see documentation. If documentation good enough, we can find something very quickly that will help us. Okay, marketing. Docker registry. Yep, Docker registry. All right, so there should be some command that I need to just run this. I always forgetting to run. Let me see if I have this in in my memory somewhere 222, and my extension of memory is my shell. So let's go deployment. Hey, let's do reg cert. Okay. All right. Secret or config map. Yeah. Okay. Sure. Now I need to change my password. All right. Let's see if it's still in error. So let me do k delete deployment. We delete deployment and we do again deployment kgp application created container. So what we did, I created a secret in order to Kubernetes to pull this image from my private Docker registry. And the way how it works, I created a secret that will include login and password to this repository. Need to remove this after. Stream topology pick. Okay, so the way how we can do this. Okay, so if so I will. This is my topology. Let's do this. Just dot so just GitHub. And I'll do this here. This is my topology, live streams. I like it. I like how it sounds like live streams. This is my topology. I created a secret only for you folks. This is a link to topology. Well, back. Why I cannot? All right, this is a gist, and if you go into this, website, this topology visualizer, you can do a copy paste this topology and paste it here, so you will see a full picture. It's too big; it not even fits here. Definitely not. Yeah, no, I'm not doing this. All right, so let's see if we have everything GP running. Okay, K9S. Let's see if our application in running state, if everything is good here. Let's see roles. So I did have some data there, so I probably did not reset fully. So let me once again reset. So in this case, I do delete deployment. I delete deployment. Application is not running. Kafka Streams application reset. This is my application reset, and raw movies and raw ratings. Okay. So now I reset this application. Let's see if those topics are actually went away. They should. That's okay. That's all right. Yeah, so for my Kafka cluster, I'm not using Kube for that matter. It's just simply out of the scope for this presentation today. But again, if you like this one, just write a comment if you want to see something like that with running Kafka cluster and Kube and connecting the dots inside the Kube. I definitely can do that. Now, okay, let's do deployment again. Okay. Apply. Okay, apply deployment. K9S. Oh, actually, let me open this in a different window. K9S. In this particular case, let me do bigger font. K9S. I really love this tool. Like, if you never heard about this one, it's a fantastic tool for the dealing with all sorts of things with Kubernetes. So application is state transitioning from rebalancing to running. So this is what you want to looking for every time when you're running your application. Once you're in the running state, you're healthy, you're ready to go, and this is where that all cool stuff will start. So let me see if I have my load movies. So load movies, and I will do this config wrong place. Gradle. And I go here and Gradle. Where is it? And we're going back to Stream Movies demo. Yeah, and the Gradle is here. Loader movies. Let's see. Load movies, application config, not Avro movies. I'm looking for load. Actually, let me see in the build script what the README says. I wrote this for a while. Okay. Where's my loader? So I do have this all sorts of scripts that load this data. Load Avro movies, and I am actually not doing this. Let's see if I'm just simply using producer. Producer. Kafka. That will do, right? So let's see if we will be able to see this data. Love it. Like security is on point. I didn't do anything, and it's just log out. My topics, raw movies. Let's see. Let's see if we will be able to see any messages here. And I will be able to produce. So I'm just using the Kafka console producer connected to my cloud, produce some data, and voila, some data just landed. And check this out. How cool is that? Like it's shows me some values. It's easy, right? So it's just a string, but it's nice to have. Now, the next thing is that we actually ratings. We need to generate some of the loader with raw rating streamer. Okay, so this will generate some random ratings and push them into Kafka topic, and we'll constantly doing some stuff. Okay, so what does it mean? Let's see. We do have our ratings Avro raw streamer. So we'll see. Did I break it? A raw rating streamer. It's okay. I can produce some ratings by my hand. In this case, I will be doing this Kafka console producer, and in this particular case I will be doing ratings. So same thing, I do have some ratings. I will populate this, and yeah, we should be able to, let's see if we can we should be able to see some data in our application, inside this application. Yeah, so we have some output. Cool thing. We'll do topics. We'll do movie average ratings, not average ratings, rated movies. I'm interested. Rated movies should include some of the messages. Let's start from the beginning. I reset this to offset. Will it retrieve it? No messages in this partition, maybe in this partition. What is the partition number 2? So no data. It's weird because it should have something. do I need to check like everything? Jump to in time, offset? No, just start from the beginning. Come on. Do I have anything there? No. What? Maybe it's not even working. You know, what is happening? It's also the things that happen. I don't believe that it's actually doing right thing. Rated movies. We just looked at this one, right? Where is it? Actual movies, and see if we have any movies there. We don't store it. No. Why? No, I don't want to produce. Am I on the right cluster? Let me check. Maybe I'm producing to the different cluster. So it is a 419Q3. And this cluster is connected to what? Just too many results. Stop. Too fast. Yeah, schema registry is all right. Yeah, it's a schema registry. It's not mine. Hey, come on. Something stuck. Like, are you still see me? Like, because looks like a stream was went down. Yeah. It's interesting. The stream is not up. What is that? Let me check. No, we're still up, right? Kafka, Avro, server, console, consumer, and let's see if I do have a right place to run this. Kafka. Avro, console, sol, consumer. Bootstrap server. And what's our Bootstrap server here? We do have this one, Bootstrap server copy. Yeah, okay. So looks like, okay, let's see if we have any data there. So, okay, now actually this works. For some reason, like UI is not responsive. Let me do this again. If I do cat some of the ratings data, if I will, kind of sort of simulate new ratings arrived, we should see some of the data will be processed, and yeah, it works. Okay, so application works. Whole follow is working. Now let's try to scale this up, right? And how are we going to be scaling this? So let's do this. Edit deployment stream movie. Okay, I promised parts of Kubernetes, so let's scale it. So the way how we can scale deployment, there's in spec, you can say the replica 2, and this is how it will go. So what's gonna happen? Air watch. Okay, so now what happened is that we started another version of this application that will, successfully executed. So let's see. Let's check some logs here. Let's get back to K9S that allows us to see some logs. This is, which one is new one? I guess this is new one. Let's take a look inside. So application is also running, but one of the things that I want to show you is how it actually distributed partitions across distributed partition where there's a kind of on the very beginning there is the command, the log information about how the partitions will be redistributed. Oh no, actually I can show you in the UI. In my here I can show you consumers, and my consumer group right now it's here is the Kafka films. So what is happening? 1 2 3 4 5. Why it's so not 1 2 3 4 5. It's interesting. I expected this to be more. Let's see, raw movies. I would expected to see more consumers. Yeah, they're all here. This just in the UI. It's supposed to be 1 2 3 4 5 6 7 8 9. So we do have 12 consumers for raw movies, 12 consumers for raw ratings, because that's a number of partitions that we have here. You know what? Let me fix this stream raw. Yeah, this one. So what it says, compiling Groovy, possible variable binding is increased, blah 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 blah. User target. Maybe I changed something in my script that I forgot what I changed. Let's see. Let's together see, because like if I would do this loader thing, that will definitely would be a very cool thing. Raw ratings streamer. So what it says, Bootstrap server, raw rating, generate random ratings. It requests user targets. Okay, I think I slightly change the way how it works, and now I didn't fix this guy, and I will do ratings util dot user targets, and that should be fine. Okay, so now we have some interesting jazz here going on. So we have some generator that pushes some data, and we will see some interesting things. So first of all, we not see much of the lag here on the movie side of things. Let me actually do it a little better. But on the rating side of things, we see actually lag because the messages are accumulating there, and we have only 2 instances of this application to consume it. So we can use the power of why so many partitions here. I created topic with the 12 partitions, which is like allows me to run some significant workloads. Now, see, my generator is quite hammering right now this cluster. There's millions of messages. It's just from one laptop, and this laptop also streaming not only ratings but also streaming this YouTube video. We're doing some stuff. Now, we want to increase the speed of this consumption. So let's go ahead and let's do here. Let's do k-edit deployment. Let's add a little bit more. Let's do, say, can I do 12 replicas? So in this case, I have a 12 instances of my application that should be potentially would be faster, right? So I'll save it here. And when I do... so what I will see, oh snap, it's pending. How many of you actually followed what I did here? Why it might be pending? Any lucky guess in the chat? I'll wait for a couple seconds for someone to help me to figure this out. I was wondering if we still have anyone here in in the stream if the people still here, people still watching. Anyone, please? Anyone? Too few partitions. Not exactly. Right now, it is a view to our Kubernetes cluster. I have enough partitions in my Kafka cluster in order to support this number of loads, but we're running is this in Kubernetes cluster that has get nodes. How many nodes? I have only 2 nodes. And remember, on the very beginning, I showed you my deployment. In deployment, I do have an affinity policy. So in this case, I actually insisting that our Kafka Streams application will be running on each node. So what I need to do here, so first of all, so I'm telling the Kubernetes cluster, hey, go ahead, scale this up to 12 replicas. No, it's not deployment. I'll do K scale, not deployment. I'm actually interested in G-Cloud resize. There should be something like container cluster resize. Yes. Okay. G-Cloud container cluster resize. And where's my Kafka Streams cluster? Let's see size. I would do east C, I guess, and let's do it 12 more nodes. So I will increase a node pool of my Kubernetes cluster in order to this cluster accommodate my my applications. As you can see, I'm still hammered. I'm like already 41 million messages behind. So let's see if we will be able to come up with something that can help us and serve this kind of problem in a real time. So also this is one of the things that you can pay attention to in production, but really not really. So the consumer lag is some good indication that something is going on with your application, but it not necessarily means that your application is down, right? So for example, we see that like it's 45 total messages behind, but what we actually looking here is raw ratings. In the raw ratings, we behind about 11 million of messages. So let's see if our scalable architecture will be able to. So yeah, I have enough nodes. Let's see if I have enough applications to run. And you see, now I'm running 12 Kafka Streams applications just by, doing the typey thing. And let's see how this 12 application will be able to consume this million messages or millions of messages. Let's see how it goes. Another thing is my application. My Kubernetes cluster is not located in the same data center as my Kafka cluster. So this is why some of the things like I'm producing some producing this kind of, oh, you see now what happens is it's going down. It's going down. It's just like will be going really slowly. We'll take it some time, hopefully. Let me quickly kill this generator and see how fast it can catch up, like just for the sake of performance or whatnot. All right. So is there a monitoring tab in Kubernetes? Yeah, probably there is. I use this use small tool called Octant. Lag is so big because my small console application was able to generate enough messages. Why is that? Why is not able to? Some pod already taken. Anyway. So the lag is big because I just generated too much messages. You can go and check my code in raw ratings. It just simply, it doesn't throttle anything. It just simply generate messages and just like hammer this cluster. And this cluster running in Confluent Cloud, and you can see that it's like a few million messages is nothing for this small cluster. So let's take a look on the life of this cluster, if I can see any like a monitoring things. I probably don't. So production, consumption, or maybe there's another thing, is that since I'm running this in a free tier account and I'm not using dedicated cluster, I just capped by Confluent Cloud, so I cannot produce more. Potentially, I can produce even more than the millions of messages, but still, it's pretty good. 3 megabits per second. Yeah, it's probably just because something is kept. It's something I need to investigate actually. Maybe or maybe the traffic between the Kubernetes cluster and, because it's going through the internet, just from the real internet. All right, so while it's doing this, we're catching up on the messages. Let's take a look at another option. So we were talking about what? Yeah, I have like a 25 more minutes, and I think this would be we'll go. It's good enough for first one. Where is mine? Yep. All right. So this is what we did. We just scaled this application. Now, how this store was replicated, actually. Let's talk about this one. So if we'll kill one of the applications, how other application will catch up and other things. So let's talk about how Kafka Streams implements the fault tolerant state. So again, this is like orange squares is your topology. This is your our topology. It's not even yours or mine. It's our topology now. So we are together in this one. Now, in the input topic, get some data, pushing data in. We're executing this topology. Now, if some updates happened in this state, we do have a processor going on. There's a Java code that constantly updating this aggregate. So some stuff is going on, and we're aggregating this local store. And after that, we need to also provide durability for this state store. So I got some question earlier today if what's going to happen if this, like, how the state store will be updated. So state store will be updated by your application, and after that, it will be replicated through a changelog topic. Changelog topic is a special topic in Kafka. So if you will go here, see the topics. So we see there's a movie stores and rated movie stores. It's actually, we're using these changelog stores, and all the messages are going into this changelog topic. I'm not sure if we actually will see something here. Yeah, because it will probably won't be able to read this message because it's like a binary serialized format that the UI will not be able to read. But if you just read this from all of a sudden, everything is extremely quiet, and I was wondering if stream still is going. Let me remove this. Let me see, where's the consumers, Kafka films, and if we're still doing stuff. Okay, so not bad. It was pretty fast. It was pretty cool and pretty fast how this application was able to catch up. Let's do it again, shall we? I will do this loader. So let's see if it will be able to catch up in the real time fairly quickly. So it generates around 30,000 messages per second ish, and let's see how quickly this application will be able to catch up. But not the point. Point here is that for each individual state store, in this particular case, if we're looking to this guy, we do have aggregate state store, movie store, and rated movie stores. Let me check if we do have this here. So this is aggregate. So this is aggregate state store repartition. No. This is not what we're looking for. We're looking for this one. This is state store changelog that will have information about our aggregates that will be replicated through Kafka. So if our application will go down, say we do resize or like a scale deployment, and say we're scaling deployment to 2 things. So let me bring back slides again. So the state store will be migrated through changelog topic, and this is why changelog topic for particular state store will have the same number of partitions as the changelog for particular state store. So this is how it will be migrated through the Kafka topic. Now, in order to recover on the other side, this state store will be replicated again through Kafka into new instance of application. So everything that happened on this like 12 instances, I just kill this by what now it's 2 instances. The state store, our like changelog topic already have this. So this is why for the rest of the instances of this application, it will replicate it back to the back to the So let's talk about how we can speed up certain things. So now for now we're using deployment. In this case, we solely depend on the way how the Kafka is doing these things, right? So the way how I see Kafka right now, I'm just answering this to CDE lags. This is I'm using Confluent Cloud just because I'm running Kafka there, and I'm using this UI that comes with Confluent Cloud. So you can go check this out. So for now, my application is solely depend on Kafka to replicate store. So even if these pods don't have any state, my application will be able to restore state in other side by simply reading changelog topic and rehydrate its own state. So this is one thing that the Kafka Streams gives you. So it uses Kafka, and if you're using Kafka and it's deployed somewhere, we'll have enough storage and things like that. You don't need to worry about anything else, right? So if your application will die, changelog topic will still have relevant information. Now, so now, can we benefit from a local state or local store for my Kubernetes application? Now, sure we can. So let's see how we can do that. So so application is still doing all right. Let's see if let's see how far we are behind on this log. So you see, when it's like one application is hammering clustered, another application will not be able to catch up. Let's kill it, and also we will delete this deployment because we're going to be doing something. We'll try something else, like application stop, and all pods are disappear. Now, next thing is that we're going to be trying to do is to create for each application, we will create a local store, and this is why we're using the StatefulSet. All right, so StatefulSet is a Kubernetes resource that allows us to have a persistent state, stateful network identity, as I said, or stateful disk identity. In our particular case, we are interested in stateful identity. So in this particular case, we're creating a volume that we call it RocksDB, size 1 GB, and this is where this will be mapped. Why here? So in this particular case, we go into Google and calling Kafka Streams state store location. And it's config, right? Config, not stole, store, and we're going to Apache Kafka location. See, okay, temp Kafka Streams. State. Okay, this is interesting. So, actually, I was confused once, and hopefully you won't be. So, there are two documentations, and one documentation comes from the Apache website, and some documentation coming from the Confluent website. The Confluent website says it's going to be warlib Kafka Streams, and Apache Kafka website says it's going to be a temp Kafka Streams. So this is not production ready place. Oops, sorry, I just moved this to another screen for some reasons. Go back. Yeah, this is not production ready place to storing your data. So this is why, like, when we build the Confluent platform, we actually do some of the, the modification. It uses the same jars, but if I'm not mistaken, I'm using Confluent Streams version of this library. So in this case, state store will be configured to use, but this is default location. You can always change this in your Kafka Streams applications. There is a Streams demo. If you go here, one of the configs that you need to pass, where's my configs? So we're doing something like config dot put config dot put a streams where is it? What's the or either stream config, or what's the name? Streams config and state store dir. So this is where you're specifying your state store, and make sure that your state store that's specified in this config will be aligned with the location of this state thing. So since I'm using Confluent library, I know that by default we're using this warlib Kafka Streams location in order to preserve this after restart, because like a temp directory obviously would be updated. So now, okay, apply F, and we do movie. Where are we? So we go into Kubernetes directory, cd streams Kubernetes, okay, apply, and we're doing this with ratings, stateful, okay, get StatefulSet. So we have this one StatefulSet, and we do okay, get StatefulSet streaming movie ratings minus O YAML, and do C minus L YAML, so we can have a nice view. So this is our stateful set that we created with two replicas. So if I will go here, I'll just get pods, two applications up and running, and if I get persistent volumes, it actually created two persistent volumes for me. So in the one persistent volume, we'll have for one each node. So if I will do edit StatefulSet stream, what's the name? The streams movie ratings. And in this particular case, if I go and create it, say replica 3, so in this particular case, I will see that it will create another persistent volume for me. So each instance of this application, and see our operations continue to perform. Now, when one of the node will be restarted, we don't need to wait until we rehydrate all the store from the Kafka. And the only thing that this matters during application startup. If you have a big state store, to rehydrate this inside your application, it will take some time. In this case, since application is not ready, you will not be able to do processing and things like that. All right, good question. Good question from Alexander. So I will answer this question with a slide. Alexander is asking, what's the benefits of having one or another? So some people think that StatefulSet is something new and maybe not super stateful or not super safe or maybe not super stable. Usually, what I like to say here, it allows your application to start up faster. Your application will have assigned persistent volume, and the previous state of your application will be stored in this persistent volume. So during the startup, your application just needs to catch up delta. It doesn't need to read all the state. If you're just doing simple stream processing in terms of like simple, I mean stateless, meaning that you're just doing filtering, you're just reading some data, filtering, writing to another topic. You don't care about state. Just in this case, you can just scale up, scale down, and then scale up based on the load. Just do quick filtering and scale this down. So in this case, whatever. Or you don't trust your storage admin. So in this particular case, you kind of, like I'm not doing this because I don't want to lose the state. But you trust your Kafka admin, or you trust Confluent with Confluent Cloud. I don't know. Like it's up to you. I'm just saying. So in this case, Kafka still will preserving this because Kafka still has this changelog topics, and these changelog topics will be replicated and stored inside the Kafka. Your application still will be able to rehydrate. So in terms of recommendations, you don't need to, like in your application, in your when you're running this in the Kafka that you manage, you can specify the size of a state store. Actually, it's a good question to investigate. So I know how to solve this in on-prem things, because you can have a control over size of your segments in your log. I need to check how this works in the cloud. It's actually a very good follow-up conversation that we talk about this. If you trust your storage, use StatefulSets, and it's pretty good. If you think about this, I just use StatefulSet for one particular reason. For this, you have a human readable names for your pods. So this is what StatefulSet gives you. Stateful network identity. Your pod will have a dedicated name. If you're using just deployment, it will append this with some random generated pod name. So if one of the pods will go down, you don't know what pod went down. In this particular case, code is named in a particular version. So let's see. Application still up, still running. And let's see if we do have. Where's my cluster? Confluent Cloud. Yeah. So all the messages are consumed. Everything is good. So far, so on. And let's see what kind of recommendations I do have for you. Use anti-affinity, because collocating to multiple application, especially because this is compute application, they do some computational stuff that allows you to have a more control over the resource allocation. So if you running this in big and packet mode, it's okay probably, but like if it's possible, use anti-affinity and have a dedicated compute node for each individual nodes. Also, during startup, let me show you quickly in my yeah. So pod management policy, it's also very important. So by default, if you're not specifying this, I guess it's just it's waiting until certain pod will be ready, and after that it will roll to another pod, and after that to another. So with parallel, you don't need to do this, and the reason for that is essentially Kafka Streams has built-in mechanism to ensure that application will ready to serve your traffic. So remember this like a state transition, the log that I showed you when you see this transition from the rebalance to running. So this is where Kafka Streams knows how to, the state is migrated itself. So this is why if you start multiple pods inside one StatefulSet using this parallel pod policy, application will start quicker. You don't need to wait. And in this case, you don't need to rely on the knowledge of Kubernetes. In this case, you rely on Kafka Streams knowledge. So Kafka Streams will be able to figure out its own state. And its own state will be managed through Kafka, obviously, because Kafka Streams relying on this coordination protocol that built in Kafka. All right. And I think that would be it for today. So let me quickly write down something to let me file new scratchpad. Where's my scratchpad? Scratch, new scratch file. Oh well, what is that? Scratch file. Yeah, and this is gonna be what something nice text. Plain text. All right, so what did we see today? So first of all, I showed you how I can build my application using Jib, build using Jib. I'm publish my application to external Docker registry. In this case, artifactory. Start Kubernetes cluster and marry to artifactory. So in this case, we tell how the Kubernetes can read this from artifactory. Yeah. Anyway, now we've seen how we can use how we can connect to this application to Kafka cluster, but it doesn't matter. Now we've seen stateless deployment using deployment resource, and we've seen stateful deployment using StatefulSet resource. So this is your key takeaway result stuff you can get from http github.com/confluent inc/demo scene. This is where you can find this streaming movie ratings. You can find everything's there. You can find me on Twitter at JMUSSA, and I don't know if you enjoyed this the way I did. Like I said, it's very difficult to read the audience, when I don't see you and you see me. So hopefully that was useful, somehow useful, somehow entertaining. Let me know if you like this format. We can hack together something else. And as always, go follow me on Twitter and submit your request. This show will be running only by request if I will have enough material to talk about. let me know. And yeah, I think we spent a very good half an hour, hour and a half, sorry, to talking about the stuff. I will share a recording for those of you losers who didn't join and still want to see. So all right, so I love you guys all. So you're not losers, just like everyone has a different time zone. Yeah, so like while we staying home, I will keep you educated and entertained. Thank you so much for being with me, and as always, have a nice day. Or I should say it with a heavy Russian accent. As always, have a nice day, right? Something like that. All right, so not everyone finished this, but hey, thank you for being with us. We need to do a picture for